So let's take a look at this one. A population of values has a normal distribution with mu, the mean, equal to 128.2, and sigma, the standard deviation, equal to 11.7. A random sample of size n equals 212 is drawn. The first question says, find the probability that a single randomly selected value is between 127.9 and 130.4, and round your answer to 4 decimal places. Now let's notice we have a normal distribution and we're finding a probability. And anytime we're finding a probability for a normal distribution, we're going to use one of our two z-scores. This question is asking for the probability of a single value. So we're not using our sample size, we're using a single value. And a single value is always going to be using the z-score that we got in our last section, this z-score right here. Now, since we're looking for a probability that is between two values, between these two values, we are going to do two z-scores, one for each of the x values, for 127.9 and then one for 130.4. So let's start with the 127.9. That's going to be our x when we do our first computation. And we'll take these two values right here as well and plug them into our z-score. So we'll go back here and let's plug in. Using x is 127.9. I'll subtract mu, which was 128.2, and divide by sigma, which was 11.7. And we want to work through this problem. So first, let's start by subtracting the two top numbers. That gives us negative 0.3. And then we need to divide that by the 11.7 that's on the bottom. So let's do that calculation. And that gives us negative 0.025641. And actually the sixth decimal would be a 0. Oh, that is 6 decimals. Okay. So now let's take this thing and put it into Excel. And I have Excel open in the background. So I'll go ahead and let me kind of move it down so I can see that value. I'll just go to this cell right here. And we'll use equal norm.s.dist, and let's put negative 0.025641 and the word true, and it tells me that probability is 0.489768. Now since we were able to round to 4 decimals, let's just put 0.4898. All right, now we're going to do a second z-score for our other x value. Our other x value was 130.4. Our mu is still the same. Our standard deviation is still the same. All right, so let's work through this. Let's do the 130.4 minus the 128.2 first. That gives me 2.2. Still have to divide it by 11.7. All right, so let's do that calculation. And I get 0.188034. Let's now look that up in Excel using the same command I used before. So equal norm.s.dist. We want to put 0.188034 and the word true. And I get 0.574575, and let's round it to 4 decimals. So 0.5746. All right, now to get the final probability that we put into my open math, since this is a between problem, we always subtract bigger number minus smaller number. And if you ever subtract and get a negative, you know that you actually put them in the wrong order. So 0.5746 minus 0.4898, and we get 0.0848. So that's what goes into my first one here, 0.0848. Now let's go to the second one. Now let's notice with part B, find the probability that a sample of size n equals 212 is randomly selected. And we still have the same x values here, all right? But they're actually means this time. They're x bars instead of x, all right? Now they used a symbol M here to symbolize X bar, but it really means the same thing as X bar. So our formula is different when we have a sample size. It's that second formula we got. And let me see if I can pull that down from a previous example I did. Let's see. I think I've got it. Let me type it out in a better form. So here's that second Z formula that we're going to use every time that we have a sample size. All right, so we're going to do a calculation very similar to what we just did with the last problem with part A, but our bottom calculation is going to be different. So let's start with our value of 127.9. You'll notice the top really doesn't change from what we did a while ago. What is going to change is the bottom. We're going to have 11.7 divided by the square root of, let's see, what was it? 212. All right, so let's work this thing out on our calculator. So the top, 127.9 minus 128.2, is really going to be the same as what we got for the top up here. It's going to be negative 0.3. But now I've got to work out the bottom. So I've got to take 11.7 and divide it by the square root of 212. And that is going to give me 0.803559. Remember, take that out quite a few decimal places. If you're not sure how many, just take all of those that your calculator gives you. All right, now I'm going to go ahead and do the division. Negative 0.3 divided by 0.803559. And that gives me negative 0.373339. All right, now let's take that and look it up in our Excel. And I'll just choose an empty cell. Equal norm.s.dist, negative 0.373339, and true. All right, and that gives me 0.35. Let's go right there. Okay, 0.354448. All right, now let's do our second X value, 130.4 minus 128.2. But the bottom of the fraction is now 11.7 divided by the square root of 212. So just like above, we can sort of cheat and look up here. The top of the fraction is still 2.2. And we can cheat a little bit here too because we know what the bottom of the fraction is. It's 0.803559. And now let's let our calculator do the work. 2.2 divided by 0.803559. And that is going to give us 2.73782. Last one is a 0, so don't really have to write that. All right, now let's look that up in Excel. And let me move this just so I can see my number as I type it in. Let's see. Maybe. There we go. Over here. Norm.s.dist. 2.73782 true. And that gives me that. I'm just going to go ahead and copy it. We'll, whoops. I'll put it down here. All right, now last step, we need to subtract these two values. The biggest one is the one that starts with a 9. And I could have, if I wanted to, gone ahead and rounded these off to 4 decimals, but I'll just do it after the fact. So let's put that into our calculator. And this gives 0.64246. And of course, if we round off to 4 decimal places, what we're going to put in is 0.6425 for our answer here.